Hey there. Oh, let me fix this. We are going live today to talk about brain networks and functional neurologic disorders. We've got a hot off the press article that we're going to review today that it's a little heavy, I'm not going to lie, looking at brain imaging in FND and really looking at the subtypes of FND and what might be different between different types. But I think take-home message is that it's the brain networks, people. It's the networks, it's the connections between brain areas that are really the issue in FND. So that's what we're going to talk about. My name is Julie Hirschberg. I am a neurologic physical therapist. I am the owner and founder of re+active. We are a integrated neurologic rehabilitation center. We're in the Los Angeles area, but we also do education and mentoring for clinicians, and we lead online membership for people with FND, people with zebra conditions, Parkinson's disease, and so much more. This week, actually, we did a workshop for people with FND, and we dove into some of this brain network science. And we opened the doors for a sale for our online FND membership community. So if you are a person with FND, if you're a family member of somebody, if you're a clinician that supports people with FND and wanting them to get connected to a community, to experts from re+active, to education and learning and practices, our doors are open and it's on sale just for this week through October 28th. So I didn't want to forget to say that. So let's dive in here. This is the article. So it's called Altered Brain Network Dynamics in Motor Functional Neurologic Disorders, the Role of the Right Temporo-Parietal Junction. And of course, you know I've got my brain here so that we can talk about all this neuroanatomy, but more important, the connection pieces. This was published in, I want to say just recently of 2025 in the journal Translational Psychiatry. And it's from the great group that I really respect out of Switzerland. The first author is Samantha Weber, last author Selma Ibeck. We use a lot of the literature out of this group. Really great group. So let's start with just introducing and understanding why they did the study. Now, I'm going to give you the disclaimer. I'm a physical therapist. Yes, I'm obsessed with the brain, but I am not a person doing this level of research looking at functional MRI, functional magnetic resonance imaging. I can't even say the word. So I'm going to do my best to describe what they did in this study because I think it's actually really cool because they looked at the dynamic activity of the functional MRI versus just static. And this is really important because what people ask us all of the time is, why are my symptoms changing? Why is this variable? Because the networks are variable. So I even want to start off with that question. Somebody literally asked this question to me, and I want to pull it up. And they asked, my symptoms are mainly episodic. Why is my brain only misfiring sometimes? So to this great question that was sent my way, I want to say, let's talk about these brain networks, right? Because when it comes to variable symptoms that might change in different environments with different triggers, we have to go to the brain networks. It's not just one brain area, one lesion. In fact, we know it's not in FND. Imaging, traditional imaging doesn't show that, but we have countless studies that show now there are differences in the connections in the brain as shown by fMRI. Now, this question actually came up also in our workshop this week. Should I get an fMRI to get diagnosed? Nope. You should not. fMRIs are done in research at this point, and they're not diagnostic. I think at this point, and even in this study, they're really looking to try to understand what has gone awry, and we can see differences between healthy controls and people with FND, but not so much yet that there's a biomarker. But I think we're going to get there. So let's talk about this article. I have it all highlighted in front of me here. I'll take this down for a moment, and let's talk about why they did this study. So first of all, multiple studies before this have shown FND to be a pathology of brain networks, and not just one network, but multiple brain networks. This is really hard to study, by the way, because all these interconnections between the brain networks, like, whoa, they kind of blow my mind every time. One of the biggest areas that has been implicated in the brain networks is a sense of agency. And I actually really like how they define agency. So maybe you've heard this before, maybe you haven't, but agency is the experience of being the active executor of an action. So that means if I have agency, I move my hand and I know that I willed my hand to move and it moved. In the person with FND, and this has been shown in some of the imaging literature, it appears that this area of the brain, which happens to be the right part of the brain, temporo-parietal junction. This is our temporal lobe. This is our parietal lobe. Here's the junction. Right temporo-parietal junction appears to be that main area where multimodal inputs and connections to provide that sense of agency, that sense of control over our movements. Many folks with FND experience a lack of control and a lack of agency. They experience it as involuntary. And that might be due to not great connections to and from the right temporal parietal junction. But other areas are also implied. So the frontal part of the brain is mostly motor areas, and there's the supplementary motor area in that part of the brain. The dorsal lateral prefrontal, so this is frontal, prefrontal cortex is another area, as well as those connections with the default mode network, which is multiple areas in the brain, and the salience network. These are all areas I have to tell you really obsessed with because of this just like really interesting understanding and trying to understand what's really happening here in FND. So in past studies, they have found this right temporal parietal junction to be hypoactive, less activity in this area that is known to provide that sense of agency. However, other studies have found conflicting results. It's been inconsistent. And some of this might be because when you're looking at FND, you're looking at many types at the same time, right? So one person might have tremor, one person might have dystonia, another person might have seizures, another person might have weakness. They all present quite differently, but they get lumped into FND altogether. And that was one of the purposes in this study, was to look at a group of people with FND, but then to subtype them as people who have functional motor symptoms with or without weakness. And I really love that they did this, because as a clinician, I often hear questions from people about their different subtypes. Like, oh, this worked really well for tremor and dystonia, but it's not working for my person with weakness. And I would say we hear this a lot, especially in regards to full lower body weakness. As clinicians, I hear a lot of people struggling with this. And I love that they actually dissected these groups a little bit to look at differences between the groups. Because I would say, as a clinician, and the things that I see are helpful to people, they might actually be different between the different groups. Now, I would also say they're different for everybody individually, but that's my bent. I don't think there's one way for everybody when it comes to FND. It's what makes it so fun as a clinician to really come alongside a person and figure it out. It also makes it challenging as a clinician. There's not a one-size-fits-all approach. Okay, so what they aimed to do, so these were their aims. They wanted to evaluate the functional alterations and connections within that temporo-parietal junction network and compare it between people with FND and healthy controls. And they used this method, which honestly, I read this article a few times. I'm still trying to understand it. They use a seed-based co-activation pattern approach. So this is the method that they used to look at these network connections in the brain based on a seed, which was the right temporal parietal junction, and connections to other areas. And they looked at it in a dynamic way, meaning not that the person was doing dynamic things in the fMRI, but that they looked at it over the period of time that the person was getting the MRI. So both in space and in time. So that was the dynamic nature of it. The second aim in their study was to identify the motor subgroups, right? So to look at differences between the groups and to see if there was differences in this dynamic piece. So, you know, I love to talk about who was in the study. So let's put it up there. I know it's really tiny, but I'll talk through it. These are the demographic characteristics of the people in the study. We have the FND group that had 58 people. Then we had healthy controls, also with 58 people. The average age was 35, and a much higher percentage of females than males in both group. The duration of illness in months. So these people had had FND for a while. It was 54 months. And then you can see the symptom types. So they did have many different types, but the primary was a sensory motor type, gait disorder, tremor, myoclonus, and then down the list. You can also see that there were key differences between the healthy control group and the group with FND. So for example, one of the criteria was psychotropic medication, yes or no, and 28 people had it and 0 people had it in the healthy controls. Also, they mentioned they looked at depression and anxiety levels. Those were also different between the two groups. And then the rest is the imaging profiles. So it gives us a good idea. This is a really heterogeneous group, but also I think that's really nice, right? So it wasn't just one type, but these folks were then stratified into whether they had functional weakness or did not have functional weakness. So then they do imaging. So they do an resting state MRI, and they also did a regular MRI, by the way, and then they evaluate this. So this is where I had to read this paper several times because, again, this is not my expertise. I'm just reading papers because they fascinate me, but to understand how they really did this. So this was called looking at functional network dynamics, and they looked at both the spatial, so it over space and over time, what are their characteristics and activation patterns and co-activation patterns. So meaning, like, does the temporal parietal junction co-activate with the default mode network, or does it actually deactivate, meaning they don't activate at the same time? So they looked at hypoactivity and hyperactivity. They looked at whether things were coupled together, meaning firing together, or decoupled together. And this was called the CAP analysis. So co-activation pattern analysis is what they did. Honestly, this was I think the first time I've read a study that looked at this. So then, of course, they're going to compare it between healthy controls and people with FND. And this is really helpful so that we can see if there really is a difference in this. So let's look at the results here. So very interesting. I love when papers have these really cool graphics. And of course, I love when they have pie charts. And this is pretty complex here, right? So I don't expect to just be like, oh yeah, that totally makes sense. But these are the co-activation pattern maps based on the right temporo-parietal junction. They did this for both healthy controls. These are the ones for the people with FND. And they found 4 distinct co-activation patterns that emerged from this. And what you can see in these pie charts is both positive contributions, that's kind of the red and yellow on the left, and then negative contributions on the right. And then you have all these different parts of the brain, right? And so maybe it's really apparent to you, like it is apparent to me, that default mode network is a very large 82% negative contribution on the right. Now, if you've heard me talk about FND before, you know that I'm obsessed with the default mode network and the salience network. In other studies, the default mode network has been found to be highly active, overly active, so that the person is kind of there's a great study that calls it motoring in idle. So the default mode network in the brain is this self-referential network, meaning your attention and energy is to yourself and internally focused. And this has been implicated in FND to really, and we know this because this occurs, it disrupts automatic movement. So they found that there was a strong contribution there repeatedly. Some of the other pieces that were positive contributions included the salience network. The attention networks were really positively associated as well. So this is actually confirming a lot of what we know. So I want to talk about there. So let me summarize those distinct findings. So what they found. So again, this is people with FND compared to healthy controls. They were found to be less likely to be in a state that was the salience network and the default mode network co-activation. So they entered that state less frequently. This is the benefit of having a dynamic assessment of the fMRI. And these patients also were more often to be in a state that had somatic motor and salience activation with default mode activation. So that really confirms they're hanging out in that state more. Now here's the other piece. So interesting. The subgroups. So people with functional weakness remained longer in the state where it was the salience and dorsal ventral attention network. So the attention networks, these would be those networks where you're attending internally to the body. These really disrupt our ability to have automatic movement, which would 100% cause weakness in anyone. These people with functional weakness had longer time in that state, that co-activation state. And so that's comparing functional weakness to people who did not have functional weakness. So very interesting. And then finally, they looked at the coupling between the right temporal parietal junction, this is our junction again, and the attention network and default mode network. And their conclusion here is that these connections with the right temporal parietal junction might reflect this is their words, a hampered flexibility in brain state switching and altered self-referential processes linked to impaired motor planning and execution. There you have it. So, and I would say, again, this is one study, 58 people, but it's supporting what we've seen already in that some areas of the brain are overly connected, some underconnected, and this can switch on and off. So again, back to that question of why might my symptoms be variable or not? Well, because it's a network issue. These networks can be switched on or off or shift their connections like that. And from a treatment standpoint, they can also be trained. So hallelujah. So I wanted to read through or share with you, they have a really hefty discussion section, but I wanted to highlight a couple of pieces, particularly for us thinking about some of the differences between people with functional weakness and people without functional weakness. And the people with functional weakness really seem to have this longer time and more disruption in those attentional networks than people without functional weakness. And what I want to say from a treatment standpoint is that we also need to hang out a little longer outside of those attentional networks. And it can be really hard to unstick them, right? Get unstuck. I don't think unstick is a word, but get unstuck, get the brain to shift from a really high attentional focus on the body. Now, listen, it makes complete sense that somebody with a neurologic symptoms would end up with heightened activation in these attentional networks. It totally makes sense because you're worried about your symptoms. You're tuning into them. And maybe a doctor even say, you better pay attention to this, right? Or you have had incidences where you're having functional seizures or you're having functional tremors and it really disrupted to your day. So it makes sense that this part of the brain would be activated. But if it gets stuck there and really, really stuck, it seems like, this is the technical term, really, really stuck. It seems like those with functional weakness get really, really stuck. We're going to need much more. It's kind of like they're dug into a deeper hole with these activation patterns, and we're gonna really have to help a person undig. And things, you've heard me say this before, things like distraction, not gonna cut it. It might be a temporary reprieve, but no, it's not going to cut it. We're going to need to do much more. And that involves then helping improve. Like if I think about if these are the patterns that gone awry in FND, what I really want to do is see how I can recreate those patterns in healthy controls that allow for automatic movement. So some of that would be restoring the sense of agency. And that would be like trying to increase some of that activity in the right temporo-parietal junction and restoring the intentional focus as well. So I think this is for us as clinicians, like, oh, there's so much that we can do. The other thing that I think is really great, they talk about this hyperconnectivity between the right temporo-parietal junction also correlated with the symptoms in people with functional weakness. So that also, correlation, not causation, but it gives us a clue or a hint that these might be related. The other thing is so the focus is on the right temporo-parietal junction, but the left temporo-parietal junction also seems to be involved. And particularly, I thought this was really interesting, seems to be involved in attention. So non-spatial motor monitoring of attention, and both of these temporo-parietal junctions, so bilateral temporo-parietal junctions, seem to be linked to predictions. And we talked about this in our workshop this week, and I talk about this a lot in FND, but the idea that the person with FND may have an over reliance on brain predictions, or that the brain has a higher reliance on predictions and is not getting updated appropriately by sensory feedback. So there's so much that we can do here. I think there's so much that we can do. I wish at this point this was diagnostic. It's not diagnostic. So getting imaging like this, your brain lighting up like this, it doesn't mean you have FND. It's just not there yet as a diagnostic tool. But each of these studies, I think every single time one of these studies is done, especially when like this one, they're actually repeating some prior things, it's getting us a step closer to that. But I think as a clinician, more importantly, this really informs me of what my therapy needs to look like. My therapy needs to provide autonomy and restore self-agency, so directly impacting that temporal-parietal junction. My therapy really needs to help balance these networks a bit to decrease some of that attentional network activity, the default mode network activity, and increase the salience network activity. And how do we do that? I love this because it's called the salience network. We get really salient things to drive home with people. We increase the salience. And another piece that we can do, by the way, if we want to decrease some of that vigilance and fear too, is we can provide people with the right amount of challenge and success with their movement. And this is not easy to do. But this is neuro PTs. We've been doing this for our entire careers, finding that right challenge that gives a person success, builds their confidence, lowers fear, and that can help switch off or better balance some of that attentional network. Again, it makes sense that a person would be experiencing fear when they've had symptoms, when they've fallen, all of those pieces. And there are things that we can do to help get them out of that rut. So it gives me a lot of hope for people with FND that there's so much that we can do. Now, I just want to scroll through here. I know I answered the question that was submitted. If you have questions, I am super happy to answer them. I'm just going to bring up this article again. Here it is. This is called Altered Brain Network Dynamics in Motor Functional Neurologic Disorder, the Role of the Right Temporal Parietal Junction. This is a free full text article. I will put it in our newsletter this week. So if you're catching this recording, if you're watching this in our videos that we post, you can comment newsletter, and I'll send you a link to sign up for the newsletter where we send all of these videos, all of our resources, and this week we'll be sending this article. And then what I'll remind you is that our FND membership is now open and it's on sale. It's almost $200 off. It's $198 off, I think, for an annual membership. Now, we created this FND membership, over a year and a half ago now, because we wanted to provide a place, a very positive, uplifting, hopeful place for people with FND, and be able to provide access to experts to answer questions, to PT, OT, psychology, all in a community wellness center surrounded by other people with FND, so a person doesn't feel alone. So we created this membership. We've had over 100 people join it. We do education classes every week. We do mind-body classes, mindful movement. We do exercises for dysautonomia. We have so many pieces to support people with FND, and once a year, we put it on sale so that people can join at a really accessible rate. When they join in an annual membership, they actually get the opportunity to meet with us one-on-one twice a year to build their personal wellness roadmap. So we create a plan, we do a pie chart together, and really recommend particular classes in education to get started. We provide resources to give those to have people give to their clinicians too, who maybe don't know as much about FND. So this membership is open and on sale through October 28th, so about a week. And you can comment on our post membership if you want to learn more about that. If you want to get in and get on this, well, it's a really, really good deal. And then I'm going to answer questions. So hi, Ryan. Ryan has a patient post ankle fracture that has shaking, bearing weight. Do you think it could be FND? Ryan, not having seen this patient or evaluating them, I'm not sure, but it's a really good question when it comes to, I have to put my brain down somewhere. But I don't have a lot of room here on my standing desk. Okay, there we go. So Ryan, here's how I would look to see if it was FND. I'd look for positive diagnostic criteria. The diagnostic criteria for FND include variability. So does that shaking come on and off? Does it change directions? Does the shaking start in the foot and move up the leg? If you hold down the shaking foot and try to suppress it, does it come out elsewhere in the body? Does it look like a tremor? If so, does the tremor, is it entrainable? This is a positive sign for FND, meaning you have a tremor. It would be in the foot, obviously, and it would train to the rhythm of another limb. So let's say this is the foot and it's tremoring, and then you did some rapid alternating movements on the other side, and that tremor trained to the other side. That would be a positive sign of FND. So those would be the screening tests that I would do. And remember, it's quite frequent that FND does develop after an injury. I think actually us as physical therapists can prevent FND from occurring, because here's the thing. Here's why FND would occur after an injury. It totally makes sense. You have an injury, ankle fracture, right? It was probably pretty traumatic. And then you go to the surgeon or doctor or all of these things, and they're asking you a lot of questions about your body. How does this feel? How does this feel? Are you still in pain? Are you still having pain? What about this? You're having swelling. Swelling decreases some of the sensory input to the brain. Your brain might even become kind of protective and cut off some of the sensation for you, so you're not overwhelmed by it. All of these things make perfect sense, and they're actually quite normal and should happen because this is what keeps us alive. But let's say that persists, right? So let's say the swelling persists and we're not getting good sensory feedback. And all of these things have really turned on that attentional network, even that default mode network of self-reference. And now our brain is hyper attuned to everything that's going on at the ankle. This is the perfect recipe for developing FND. And then I stroll in as the PT and I'm giving a ton of internally focused cues. I'm constantly asking about pain. I'm not, Ryan, you're probably a better PT than I am, but I'm just thinking about my early days as a PT, and I was probably causing FND. I'm just saying, because I was like an internal cuer. That's like what I learned as a PT. So us doing that on top of an injury, on top of the attentional networks, on top of maybe a really traumatic injury for the person, on top of maybe some sensory changes and stuff, perfect recipe for FND developing. And also, a person can have shaking in their muscles when they're really exerting themselves, and it could totally not be FND either. So that's why it is important to look at those screening tests: variability, distractibility, suppressibility, entrainability. All of those would help me understand if shaking in the foot after an ankle fracture is actually, FND. And let's prevent FND from occurring. Let's give externally focused direction to our rehab rather than internally focused. Let's provide a lot of safety and support and enhanced expectations around what is possible for a person with an ankle fracture. Let's give them some more sensory input. If they're having a lot of swelling, if their brain has become really protective and disconnected them from their foot, let's build up that connection. Heck, I might even be doing some mirror therapy. I might be doing a lot of things there to help a positive connection to the foot to prevent FND. My guess is it's probably not FND. And you could prevent FND. Like maybe it could be becoming FND, but let's prevent it, right? The other thing I would say, because we know there are some risk factors for FND, things I would screen for and support in the person are hypermobility, dysautonomia or POTS. These are not FND. These are things that can coexist with FND. Mast cell activation syndrome, again, not FND, could coexist with it. Not as high. EDS is the one that comes up in the literature. And then also supporting the person with neurodivergence. So autism, ADHD, also more prevalent in the FND population. So again, if we can do rehab for injuries with those things in mind, I think we could prevent FND for some people from occurring. That's my soapbox for today. Really great question, Ryan. Thank you so much. And thank you all for just showing up, for being curious about the brain with me. Every week I'm reading articles and I actually put them out on our stories to vote what topics you want to hear about. The brain networks just won by like a little bit over sensory and FND. But these are the things that I'm just going to keep sharing about because they fascinate me so much. And the literature is changing and growing daily, which is so cool. And again, if you have FND, if you have a family member, if you have a patient with FND, now is the time to get in our FND membership. I will say, by the way, we keep our membership small, so we're only bringing in 30 new members. We actually have 22 of those already. So we have 8 more spots for you, for your family members, for your patients. We'd love to have them in our membership. And yeah, thank you. Thank you so very much for joining me. And let's stay in touch. You keep telling me what you want to hear about. I'll keep reading articles. I'll keep sharing what I know. And we'll stay curious together. Thanks so much and have a good night.